Okay, this is up. That's live. This is live. Okay, welcome back to another exciting day of talking about lung health. Very exciting. Now, lungs, interestingly enough, over the past couple of years have become very they're much more in the spotlight than we have it in recent memory, or at least I remember learning. But obviously, over the past 2.5 years, the lungs have become a little bit more important for certain reasons, and the mainstream has heard a lot about lungs. So I figured let's talk about them today because there's always arguments. What organ is the most important? I think most people will say the brain, but then the brain can't exist without the lungs, and we wouldn't process any toxins without the liver or the colon or the bowels. So it's kind of cyclical. The answer is just yes, but it's important to understand that we live in a world where, in reality, all of these things work in harmony with each other. So while it's great that we have specialists for emergency situations, the reality is most of the challenges that we face in the health community are not emergencies for the most part. They're chronic that tend to develop over time and then manifest in emergencies later on. But then what happens is most of the time it's either, there's not much you can do to help, et cetera, et cetera. But the key to understanding all of this, and we're going to get into this in this talk, is to just kind of keep that in the back of your mind that everything is everything. Everything is related, codependent, interrelated. That all plays a role in the respiratory system. Now, talk obviously about the respiratory system in my Breathe Easy course, which you can check out on my website, website@wellness.com. It's basically relearning how to diaphragmatically breathe using your nose. I think anyone can benefit from it. If you're sleeping, low energy levels, asthma, allergy, chronic infections. This is something that is, I think, baseline, and it's something that anyone can benefit from, especially if you or someone you sleep with or someone snores. Super, super helpful. So let's just jump right into it. So what is the respiratory system? Now, again, this is going to include your nose, your mouth, your windpipe, trachea, and of course your lung, but also the diaphragm. Now, keep that in mind because we're going to talk about it. So what happens is in inspiration, the diaphragm is going to contract, which means that it actually contracts downward. So the diaphragm actually contracts downward to create a negative pressure. And with that, it helps air come in and the lungs expand. When the diaphragm relaxes, it actually just helps passively almost push air out. Now, obviously, you can expel it when you try to take a stronger breath in or blow out but in normal breathing patterns, in your rest breathing patterns, it's really a passive relaxation that allows for the diaphragm to relax. Now, what controls it? Now again, remember what I said. Everything causes everything. So when we talk about respiration, we have to talk about the nervous system. And this is here, me or other people kind of in one of the first things we kind of have to talk about or balance is the nervous system. Now, why usually in these types of things, we're talking about the autonomic nervous system. Now, I've talked about this one, but it's basically broken right into your parasympathetic and sympathetic nervous system. Your parasympathetic is going to be your rest, digest, but also repair. Really important, especially when we sleep. Most repair happens during the sleeping hours. It's going to stimulate your immune system and it's going to repair tissue. It also is really important for when you eat, because when we are in a parasympathetic state, that's going to stimulate more blood to the digestive system and support that. That means more blood goes to the liver and gallbladder to secrete bile. More blood goes to the pancreas to stimulate enzymes to be released to help break down your food. More blood supply goes to the stomach to create more hydrochloric acid so you can break down your food better and you're not dealing with GERD indigestion. So much of this stuff comes back to balancing this autonomic nervous system. Now, it's actually located. The parasympathetic mostly comes from the cranial region and the sacral region. On the other hand, is really located in the thoracic and lumbar regions of the spine. So again, when you're talking about everything is connected to everything, if you've ever been to a chiropractor and they're like, oh, well, your T1 or T2 or T3 can affect, your blood pressure or affect, how your heart is functioning. This is where that stuff comes in. Now, remember, your sympathetic is your fight or flight, right? It keeps you alive under stress. And remember, as much as we want to live to tomorrow, if we're not living through today, that's not great. So this is why we have this fight or flight sympathetic mechanism, is so that we can respond, we could run, we could fight, we could run away if we need to. Now remember, so it's designed to keep you alive under stress. It's going to increase your heart rate, it's going to increase your blood pressure, it's going to increase blood sugar short term so you can utilize that blood sugar and get it brought into muscle so that you can keep running, fighting, or whatever you have to do. It's going to raise cholesterol and it's going to raise hormones. Why? Because remember, you need cholesterol to create all your sex hormones, all your stress hormones. You need cholesterol to do that. And in this case, the blood supply is going to be shunted away from the gut. It's going to go to the muscles. It's going to go to the lungs so that you can get that moving at a faster pace so you can function. Now, remember, this is an ingenious design because, again, if it's going to keep you alive in the short term so that you can live another day. The problem is we get caught up in that long term, and that's when it becomes a problem. Now, when it comes to the diaphragm, there's a mnemonic we learned in school, and anyone who's probably taken some further biology classes have heard this mnemonic. It's called C4, C3, 4, and 5. Keep the diaphragm alive. So what happens is there's this phrenic nerve that comes down from the neck, and it goes down to the diaphragm and attaches, and that's going to be essentially what controls that pumping of the diaphragm. So if you do not have that function in the middle of your neck, again, sometimes this is why going to a chiropractor can be helpful to optimize that to help your breathing. This is why you need to have or maintain that backward C curve in your neck. If you have a straightened neck, that's going to put pressure on those nerves in the neck, could affect how you breathe. So if you see a forward head carriage, chances are they have impaired breathing, or they're mouth breathers, or they're not doing full belly breaths because they're putting stress on that nervous system. It's coming down, and the poor posture is essentially leading to not getting as efficient breath as you possibly can get. So what are the main stressors that we're talking about here? Again, there's 3 types of stress. Talk about this all the time, but it's worth coming over. You have your physical stressors, and again, that could be your forward head carriage, that could be, injuries. You have your chemical stressors. These are going to be, again, the biochemical stuff that we talk about all the time, and then emotional things like anxiety, depression. Maybe there's some sort of brain dysfunction. Maybe there's impulse control, hypertension. There's tons of different things that affect this, and how it kind of comes back to dealing with everything, causes everything to some degree spread out. And then they go into these almost group structures called alveoli. And these are where you're going to have arteries and veins. And what happens is you're going to have arteries that bring blood to the alveoli from the heart, from the right side of the heart. This is deoxygenated blood. And there's a transfer of oxygen from the alveoli to the oxygen blood to the side of the heart, and then get circulated through the body, and then the cycle is going to repeat. You remember, we're talking about CO2 is actually chemosensitivity. Oxide is the trigger to breathing. It's actually not oxygen. well, or to a lesser extent, it's oxygen. It's first carbon dioxide, pH level, and then finally it is oxygen level. So what actually stimulates or is your stimulus to breathe is a change in the partial pressure of carbon dioxide in your body. So really important kind of how that can work. But what we're talking about when it comes to stress, so if there is stress, again, there's plenty of studies that go back. We know that stress can increase lipid concentrations and increase blood viscosity. In other words, blood gets thicker. So not things necessarily you're looking for, again, when you have stress, and these things can change. Now, also, what's interesting is if you're going to slow down blood flow, you're going to have more issues oxygenating your body. So if you're under stress for a long period, is it chemical? Is it environmental? If we take an example of asthma, now normally say, you have a blood vessel that's this big, maybe in an asthmatic, it's tighter. And maybe during an attack, it gets even tighter. So as that pressure builds, you're going to have less blood that's going to be able to get funneled to the lungs, to these alveoli to get oxygenated. You're going to have less blood getting to your tissues. And then all of a sudden, everything starts to slowly fail, essentially. You're not going to be functioning at your best because you're having this tightening of blood vessels. If they're not open wide like they should be, to get more blood in, we're going to be less blood out to your other tissues. So the important idea to kind of keep in mind is that the more we can keep these blood vessels open wide, the better chance we have to oxygenate our tissues, both in a stress state and in a sympathetic state and in a parasympathetic state. It's just a question of redirecting it where it's supposed to go at a specific time. And if there are environmental stressors that are, say, causing things like asthma, and we're going to get into that in a second, these are going to be issues both in a sympathetic state and in a parasympathetic state. So let's talk about asthma a little bit, because it's interesting, because according to the WHO, and according to the Lancet, to be one of the most prestigious journals we have, we know that asthma is dominantly a disease of the privileged class and tends to come along with those who have higher education levels and generally higher income. Now, isn't that interesting that asthma is more widespread in generally countries that tend to be better off and those who have higher incomes? And again, in the Lancet, a disease of affluent societies, where increasing to increase the prevalence of. So why is that? Again, we kind of talked about this before. Why, even though we have the best doctors, even though we have the most expensive equipment, even though we're the most quote unquote civilized people, why are we getting dramatic rises in things like asthma that don't exist in less developed countries? And there was this idea, of this hygiene hypothesis that I've talked about this a lot, but if you're talking about, some of the gut stuff that we've talked about in the past, there's this idea of the hygiene hypothesis. Particularly, I remember when I was a kid, it's about keeping everything sterile, keeping everything clean. But we know now that, the gut plays a big role, and we don't necessarily survive well in strictly sterile environments. And it's interesting because we know that if you tend to live in a rural area, these are consistently associated with lower prevalences of asthma compared to more urban areas. If you have an exposure to farm animals, or if drinking unpasteurized milk, raw milk, these people tend to have, again, more protection against asthma. If there are pets in your house, or if you happen to live in a large family, these tend to be protective measures against asthma. So wait, I thought, that everything had to be spick and span, everything had to be clean. Well, what we're finding is that the more microbial organisms in the environment, it helps build a kid's resistance to asthma. And this makes sense because now we're talking about getting questions on breastfeeding. Well, with infants, you're generally a lot of the initial immune responses that a child's going to get is ideally exposure to a mother's milk, and that's how they actually inherit a lot of their initial immune system from the mother. Their exposure, ideally, normally, should be through the vaginal canal at birth. That's actually how babies first get inoculated, so to speak, with helpful bacteria. It's actually through the vaginal canal during the birthing process. Um, and it's really interesting because, again, we try to live in a world where we're sterilizing everything, yet these things continue to get worse, which is really interesting. So, when it comes to asthma, like, we really have to kind of take a step back and be like, is it this hypersterility that's going on, or are we not exposing ourselves to enough different types of things, especially in early years, that could potentially be leading to it? And when you're talking about using potentially, baby formula that's with cow's milk, that's usually pasteurized and filled with other oils and sugars and sweeteners, we know those are things that are going to lower the immune system dramatically, particularly early on. And we wonder why we're seeing a rise in asthmatic kids that didn't really exist a generation or two ago. And again, we're starting to see this come out in studies. So there was one in the Journal of Clinic and Experimental Allergies that they noticed that antibiotic use in infancy may be associated with increased risk of developing asthma. That's interesting. Again, it goes back to this kind of idea of sterility. Another one in the Journal of Allergy and Clinical Immunology, there is an association between antibiotic use in the first year of life and current symptoms of spinal conjunctivitis and eczema in 7-year-olds. So wait, so what's going on here? We're saying that if you're using an antibiotic on a 1-year-old, on an infant, you're seeing symptoms in kids that are now 6 and 7 years old. So that exposure, that immune system exposure early on, dictates how that kid is going to grow up and how their immune system is going to react years later. Yes, I'm seeing an IG here, Kelly. Yes, certain injectables can be related to it, but we can't talk about that here. So we're not going to talk about that right now. Other things that are really, although it is right, I don't want to pass over it, but I also can't really talk about it. So I want it to seem like I'm glossing over it, but there are things that show that there is a relation with that. That's about as far as I can go with that on this talk. But there is definitely a relationship with that. So that's important to kind of keep in mind. And that's a question for unfortunately. Unfortunately, free speech is not a thing we have at the moment. But yeah. Another big one here is glyphosate. Now, I've talked about this in the past. I haven't done videos on it in a while, but one of the first videos that I had that I guess gained a little popularity, so to speak, was on glyphosate. And now you'll hear a lot of companies talk about glyphosate. And this is essentially an antibiotic. Now, the proponents of glyphosate will say, well, glyphosate works on the shikimate pathway and humans don't have the shikimate pathway. So how much can it really be affecting you? And, on face value, if you don't look any deeper than that, they're actually correct. Human cells do not have a pathway known as the shikimate pathway. So their argument is that, hey, well, that can't affect humans in a negative way, right? Well, that's unfortunate because what do have shikimate pathways are bacteria and fungi that live in our intestinal tracts that make up the gut microbiome. And you have to remember, we're outnumbered 10-1 microbial non-human cells to human cells. So if these are so if you are essentially taking an antibiotic every time you have non-organic grains, non-organic wheat products, these are functionally working as non-prescriptive antibiotics. Interestingly enough, residue levels are permitted in food that are 400 to 800 times greater than the antibiotic threshold, and concentrations shown in clinical studies to damage mammalian tissues. So we're seeing that these could be sprayed at much higher rates, but we're told that it doesn't affect because it doesn't show effects on human cells. So you have to understand, like, these are the loopholes that are usually jumped through to use things like this. And if you ever seen Dr. Stephanie Seneff, I suggest looking her up because she uh, will really goes into the, I think, it detail, and anyone that I know uh, better in more detail. So if you're looking for more on glyphosate, I would check out Dr. Stephanie Seneff. She does the most on it. So, and the impact that this can have, again, in the Journal of Toxicology 2009, a real cell impact of glyphosate-based herbicide residues found in food, feed, or in the environment has thus to be considered in their classifications as carcinogens, mutagens, and reproductive toxins. This is what glyphosate can have down the road. This is why everything is everything. And it's really important to take into mind here that if we're getting exposure to antibiotics as kids, either through prescription or non-prescriptive rights, this is going to affect the microbiome. This is going to affect how the immune system functions. Because remember, 80% of the immune system is in the gut. So if we're disrupting the gut, that could disrupt the immune system. Now we're talking about immune system insults, and now we're talking about potentially leading to asthma. This is how this all comes together. And it's really important to kind of keep that in mind. So that is kind of where our kind of head needs to be. Like, if you realize that everything is causing everything, this is where this stuff starts to get more interesting. Now, interesting also, there's BT corn. So this was basically, they created BT corn, genetically modified corn that basically they produce herbicides in their pollen, and I guess that the people on the tech side thought nature wasn't good enough, so we're like, we could do it better. And when they find BT toxin to raise the corn, it actually ends up in the feed of the animals, and then ends up in the humans, and particularly women, it ends up in pregnant women. So it's the digestion of the cow, survives the digestion of the cow, the human mom, and then it actually found in the baby offspring, the human offspring, they actually found it in the placenta in human-born babies after those that have had this genetically modified corn. So you have to realize that some of these things that we say we don't have answers for, they actually can come further down the line through these exposures that we are not necessarily as aware of or taking account of on a daily basis. So I wonder why, because you remember, really the genetic modification of food didn't start coming around until the late 80s or 90s. So you're wondering why a lot of kids now are having issues after consuming genetically modified foods with herbicides, with glyphosate, that are having issues with these kids. It's because these toxins are surviving the cow's digestion, then surviving the mom's digestion, and now leading to a generation of kids that are now growing up with a lot of symptoms that pretty much did not exist 30, 40 years ago. So it's really important to kind of keep that in mind. And this is why, partially why, I am so adamant about talking about breath work and using it as a tool, because it's one way, again, to build up nitric oxide production in the body. So you can do that with nasal breathing. So we actually produce nitric oxide in the nasal cavity. The only way to get it in to the lungs is by nasal breathing. If we're going to that, if it's a which has antibacterial effects. Inflammatory effects means that it can be more efficient, the air that you get in, and the blood becomes oxygenated and works better than with mouth breathing. So really important. Again, I would highly suggest checking out the class. You can do breath holds. Breath holds are really helpful. That's what a lot of the course talks about. And I would suggest doing them. You can do it in and out. Take a breath in, take a breath out, hold you could start at 10 seconds and build your way up. Return to breathing through your nose. So you're not going to reintroduce it with your mouth open. Your mouth is going to stay closed the entire time. So really important to master that, build up this, because it's going to be a really, really that you can use to build your lungs and then build up your immune system. And again, we got to go back to the microbiome here. Now, remember, 80% of the immune system is located right around that gut lining. That's the interface. Your gut essentially is the interface between the majority of your immune system and the outside world. And you have to remember, we have roughly 3 pounds of bacteria inside of us at any given time. And they outnumber that. Even though it's such a small amount, they outnumber human cells roughly 10 to 1. And roughly 85%. Now, we don't use, we do know most of them probably beneficial effects. And even the ones we can bad aren't necessarily bad. They are considered opportunistic. In other words, when there is an imbalance, they tend to overgrow, and that leads to symptoms. This is what you see in a lot of dysbiosis, or what we call intestinal permeability, or what we call yeast or fungal over. This is what it is. It's essentially trying to keep those in check. And to, when you talk about cleanses, it's really not about flushing 100%. It's about restoring the balance between all these. And this is why, again, viruses are really important. So you have to realize that viral elements, there are viruses play a role in at least 50% of our genetic makeup, our DNA. Over or around 4 quadrillion viruses in your body. Now, that is a comprehensive amount of viruses. That's, again, after trillions come quadrillions. That's another 3 zeros 4 times. So this is an incomprehensible amount of viruses that we have in our bodies at any given time. So, when we say like, oh, this is going around, or oh, something's going on, my question really is that happening, or is there an imbalance, or is something going on in the host that is allowing one to express itself in a different way? Really important to kind of keep that in mind. So we also know that viruses, believe it or not, can actually be beneficial for asthma. So what they found, there was a study out of the British Medical Journal. They found that repeated viral infections other than lower respiratory tract infections earlier in life may reduce the risk of developing asthma. This means, again, goes back to that idea we're talking about earlier. So if kids are getting exposed, if they're getting outside, if they're getting out in nature, yes, they might be getting sick, but this is actually their way of their immune system adapting to the real world environment. And as you grow up, they tend to be better off. Instead of this kind of other idea that we tend to keep talking about, where it's, oh, we need to be sterile environment and everything needs to be clean. Again, we notice in those environments, those tend to be more likely the people who are having generally sicker kids growing up. So even though kids might get sick, infants might get sick a few times, that is literally just their bodies trying to figure out their immune systems and letting them, really important. Viruses are in our bodies at all times. They literally make up or play a role in about half of our DNA. So this idea that something's spreading all the time, that it's likely already there, and it's just a question of expressing it in a different way. We also know, very interesting, in the European Journal of Public Health, they found that if babies are given Tylenol or acetaminophen within 6 months of their life, over 20,000 kids were in the study. They found 6 to 7 years old who had received the medicine once per year were 70% greater risk for asthma, while those receiving Tylenol once a month were 540% more likely to have asthma. And even those who had a single dose of Tylenol before their first birthday had a 60% increased risk of developing asthma. Those are wild numbers, but that's also pretty crazy because now you're saying, what is that doing? That's affecting the body's ability to respond to an insult. And remember what I said, babies, especially if they get sick, that's okay because they need to learn, their immune systems need to learn how to handle an environment. I think a good way to look at it now, and I'll credit Brad by giving this example because I loved it. Like you have to look at viruses or when you get sick as a software update on your iPhone. So it's literally an exposure to something new or something that you might not be used to, but it's essentially an update. So yeah, you might be sick for a couple days. Eventually you'll get better. But what happens is now you come back a stronger person. This is what happens when babies get sick. But if you try to intervene generally with pharmaceuticals like Tylenol, that's going to blunt that response. So yeah, you might get a better, you might have less symptoms short term, but clearly this is having long-term effects in some way. We also know that Tylenol depletes glutathione. Now, glutathione we know is the master antioxidant in the body, right? We need it for proper liver detoxification. This is why I think milk thistle and burdock root and dandelion and all these tons of herbs are great for the immune system. They help stimulate the production of glutathione. This is why I saw something come up on NAC. So NAC is a precursor to glutathione. So sulfur-rich foods. You need sulfur-rich foods. So your cruciferous vegetables, your garlic and onion. These are going to provide the amino acids you need to create glutathione in the body too. So all of these things you can get from food and get from the environment to help improve that immune system function and they'll help the liver do its job by getting more antioxidants. Vitamin C, really key here. Things like citrus, strawberries, tomatoes, broccoli, a lot of crucifers, mangoes, cabbage, kiwi, sweet pip, bell peppers, really, really good. Even potatoes. We know vitamin C is really good at helping protect your lungs, and it works even better if you're getting it from whole foods. You can also use things like vitamin E or iron-rich foods can help with this too. And again, in the plant-based space, things like legumes, lentils, nuts, seeds, chickpeas. All of these are really good choices, but you have to make sure your digestion's on point to make sure you're getting the most out of them. Also, what can help is some vitamin A-rich foods. So again, these are going to be most of your orange foods, your potatoes, your squash, or carrots, but also things, leafy greens tend to be pretty rich in this, spinach, kale, collard greens, mustard greens. These are all going to be really useful. Now, if there are, colds you get, things like echinacea, elderberry can be really useful to help enhance the immune system, not just to blunt symptoms. It's going to help enhance the response, optimize the response, not just blunt symptoms. So that was a lot. I know we covered. We're going on 35 minutes. That's a lot on lung stuff. So I hope that makes sense. Like I said, I'll save this. It'll be on YouTube. I'll try to save it here on Instagram too. Appreciate the support on the YouTube channel. And nutrition's obviously a big role, but where the exposures are really key when it comes to lung health, especially with kids. I know I plan on hopefully being a parent sometime soon. So this stuff are things that we take really seriously. But just educating is really important on this. I hope you found it, really helpful. And two things. I know if you want, I would say check out the Breathe Easy course, which is on my website. Again, IG, I have the code right here, Breathe Easy 20. You can save 20%. You can go to my website, insideouthealthwellness.com. The courses, you get it there. These are exercises that I recommend to most patients. I did it today as well. I was just like, look, you can do the stuff at home. It's going to help. And then get on some of those foods, those vitamin C rich foods, sulfur rich foods, vitamin A and E rich foods, iron rich foods. All of them are going to be really helpful. Short term, you could look at things like echinacea and elderberry, ginger, but that's what it is. Thank you for hanging out. I will see you guys next week. Have a good one. Peace. Okay.